This is part 3 of section 2.2. Our last little topic here is definition of even and odd functions. Okay, now this is going to seem like a weird kind of section, but that's okay. We talked a little bit about part of this in the last section in 2.1. Okay, we did a problem and I said it was going to come up later. The function f is called an even function if, when we plug in negative x instead of positive x, our function does not change. Okay? Basically, that's what it's saying. I think of it as the function absorbs the negative. And this would happen on something like x squared. Because if you plug in negative x and then you square it, you still get x squared. This exponent is one of the reasons they call it an even function. Now, if it's even, then we know our graph is symmetric about the y-axis. So if it's an even function, it'll look something like this. Okay, now I just drew a basic shape here, but you can see that if you fold it on the y-axis, it matches up. So this can actually, when we get to graphing, if we know that our function is even and it's not really a difficult calculation to make, then every time you find one point, you find a second point. So you can use the symmetry to get it drawn. Okay, now the function f is odd if when you plug in negative x, it's the same as multiplying the original function by a negative. Okay? Odd functions are symmetric about the origin. Okay? Now origin symmetry is a little bit weird. So basically, if I had something up in this quadrant and it did this, then it's going to appear down here. Imagine folding your graph from here to here and then here to here. So fold it down and then fold it right to left, and your graph is going to look like this. Okay? And of course, it could come in from the other direction. Okay? So this is sort of like, it's basically reflected and across the origin. So this would be odd, and this is even. Okay? Now, of course, a lot of graphs are not symmetric about the y-axis, and it's not symmetric about the origin. So we're going to have our problems that say, are the following functions even, odd, or neither? And then we'll state the symmetry, if any. Now, I'm going to work through these using the definitions, and I'm going to show you a trick that works for some types of problems. It does not work in all of them. Otherwise, I just teach you the trick. Okay? So f of x is equal to x cubed minus x. I want to find f of negative x and see what happens. Okay? So this is negative x cubed minus negative x. Okay? Now, well, this is a negative 1 right there, correct? Okay, and if it's a negative 1 and you raise it to the third power, negative 1 times negative 1 times negative 1 is negative 1. So this is still negative. So I'll have negative x cubed minus the negative x is plus x. Okay, so we found f of negative x, and that's required for both of these. We calculated this in one of the problems in 2.1. We plugged in negative x. Okay, now we look to see if it's even. If it's even, this should be exactly the same as this. And that's definitely not true. Okay, so at this point, we know that it's not even. Okay, now what we want to do to check to see if it's odd is factor out a negative. So what I have right now is negative x cubed plus x. If I factor out a negative, I get x cubed minus x. Now I look to see if what's right here is equal to what's right here. And it is. So since that's exactly the same, this is an odd function. Okay. What this said was when you plug in negative x, you should get, it's the same as multiplying it by a negative. And that's what we have here. We have negative f of x. So this is odd. State symmetry, this is going to have origin symmetry. Okay? So let's do the same thing with g of x equal to x squared minus x. We need to find g of negative x and see what we get. Okay, so I have negative x squared minus a negative x. Well, this is negative 1 squared, which is positive 1, so this is just x squared. Minus a negative x is plus x. Okay, so our first step is to see whether it's even, because that's the first calculation we end up doing anyway. X squared plus x, here I have x squared minus x, so I know it's not even. And by the way, a function cannot be both even and odd. Doesn't happen. All right, so this is not even, so what we're going to do is we're going to take x squared plus x, and we're going to factor a negative out of it, which gives me negative x squared minus x. And now we look at this, and is this the same as this? No. So at this point, we know it's not odd. Okay, so is it even, odd, or neither? It is neither. So this has no symmetry. Okay, let's try this one. H of x is 2x squared plus x to the fourth. We find h of negative x. So I have 2 times negative x squared plus negative x to the fourth. When I square a negative number, the negative goes away. So this is simply 2x squared plus, remember this is negative 1 to the fourth power, which is positive 1, so this is plus x. Now compare this to this, and I got exactly the same thing. Oh, except I left off the 4. That's better. Okay? So since this is the same as this is going to be even. I do not need to continue and try to find whether it's odd because it can't be both. Since it is even, it has y-axis symmetry. Okay, now I told you there was a bit of a trick for some problems. If you look at these ones we did here, boxing them so they're a little bit easier to identify. These are all polynomials, okay? When you have a polynomial, you can just look to see whether it's even or odd. And what you look at are the exponents, okay? I'm going to write in some understood exponents here. That's understood power of 1, this is power of 1, and this both has both written. Notice here, I have 3 and 1. 3 and 1 are both odd numbers, and I have odd symmetry. Here I have a mixture of even and odd, and I don't have either. Here my exponents are both even, so I have an even function. With a polynomial, and this, I told you this trick doesn't work in all cases, and it's not safe to use here either, okay? But if all of your exponents are odd, you have odd symmetry. If all of your exponents are even, you have even symmetry. If you have a mixture of exponents, even and odd, it's going to be neither. Easy, quick check. Okay, now this is not a polynomial. You have the square root in here. So that trick doesn't apply anymore. So the first thing I need to do is I need to find f of negative x. Okay, so this is negative x squared times the square root of 1 minus negative x squared. Okay, well, what happens when I square a negative x? Anytime you're raising negative x to an even exponent, the number goes away, the negative goes away. So this is x squared times the square root of 1 minus, again, I have x squared. Now, is this the same as this? Yes, it is. So this is even. And it also has y-axis symmetry. Okay, now I know this was a very disjointed section, but everything we did here is going to be a small piece of a bigger problem later on.